Good morning, students. In today's lecture, we are going to start with the next part, that is fluids part of properties of bulk matter, that is fluids at rest. In fluid at rest, first of all, as the name is indicating, in this we will consider the fluids in state of rest. What do you mean by fluid? Fluids are those material or those substances which has the tendency to flow, which has the tendency to flow. For example, you can say liquid and gases. Liquid and gases both are fluids. Now the next is fluid exerts force. How we can say fluid exerts force? If you take, this is a container in which the liquid is present, in which this is supposed to be made up of large number of atoms or molecules, and these atoms or molecules are in random motion. They collide with the walls of container as well as with each other. Suppose the molecule is moving with the velocity v. Okay. After collision, it come back with the same velocity. So its mass is m. So now what is the change in momentum? This is the final momentum minus initial. So it is minus mv minus of mv. So it becomes minus of 2mv. This is plus and this is minus v, final velocity. So here you can say that force is equal to delta p upon delta t, and it is minus 2mv. It is not equal to 0. This means the fluid exert force. Fluid can exert force. Now after this we have liquid in equilibrium exert force normal to the surface. कैसे प्रूव कर सकते हैं? How it exert the force normal to the surface? And let us suppose this is a container in which the liquid is present, and here this is a imaginary box you can consider, right? To prove this, we assume that in this the force is acting in which direction? At some angle. The force is acting at some angle. तो ये force है, तो इसकी normal reaction कहाँ होगी? Upward direction में. It make an angle theta with the horizontal. You can resolve it into two component, r cos theta and this is r sin theta. R cos theta, and r is equal to क्या है? F, क्योंकि liquid is exerting the force on it. Now because the liquid is in equilibrium, therefore r cos theta must be equal to 0. r is not equal to 0, therefore cos theta equal to 0. तो theta कितना हो जाएगा? 90. This means this normal reaction is perpendicular, or you can say that the force act perpendicular to the surface. Right? Now after this the next topic is pressure. In class 11th you have studied, 9th you have studied about the pressure. What is pressure? Pressure is the force exerted per unit area, or you can say this is a thrust acting per unit area. This is force acting per unit area or thrust acting per unit area. What is its SI unit? Newton per meter square, or it is pascal. Unit of pressure is Newton per meter square or pascal, right? अब इसकी कुछ applications आपने lower classes में पढ़ रखी होगी. Why the knives are provided with the sharp ends or the pointed ends, so that for a given area, for a given value of force, the pressure is inversely proportional to area. If area is small, then pressure is more. Drawing pins are provided with the pointed ends. Pointed ends हैं तो area small, pressure more, right? So you can see the example from the book. Next is density. Density is mass upon volume. Mass per unit volume. Its SI unit is kilogram per meter cube. And what do you mean by relative density? It is density of substance divided by density of water. Density of substance divided by density of water at 4 डिग्री सेल्सियस. तो आपके पास ये दोनों डेंसिटीज आ गई और इनका रेशो क्या रहेगा? इट हैज़ नो यूनिट. यू आर कंपेयरिंग द डेंसिटी ऑफ सब्सटेंस विद द डेंसिटी ऑफ वाटर. नाउ प्रेशर exerted by liquid column of height h. This you have to find. This is a container in which the liquid is present up to the height h, right? So rho is the density of liquid. What is the pressure it exerts? Pressure is force upon area. So what is the force it exerts? mg. तो mg is the force और a is its base area. तो m को आप क्या लिख सकते हो? दिस इज एज वॉल्यूम इनटू डेंसिटी इनटू g डिवाइड बाय a. तो अब इसका एरिया, वॉल्यूम को क्या लिखेंगे? एरिया इनटू h इनटू डेंसिटी इज रो इनटू g. तो a से ये क्या हो गया? कैंसिल. तो ये कितना आ गया? h इंटू रो इंटू g. तो प्रेशर एक्सर्टेड बाय लिक्विड कॉलम इज h इंटू रो इंटू g. Now after this we have Pascal's law. Pascal's law. क्या है ये Pascal's law? If the effect of gravity is neglected, then pressure at every point of the liquid in equilibrium remain same. Pressure हर point पे क्या रहेगा? Same whenever the liquid is in equilibrium. Or you can say that if there is an increase in pressure at any point, if there is increase in pressure at any point in the liquid, then that increase is transmitted equally to all the parts of liquid. अब हम इसका प्रूफ करेंगे. First, this is a container and in this the liquid is present. Rho be its density of liquid. ठीक है. So now we consider 2 points A and B. You imagine a right circular cylinder passing through these 2 points and h be the height through which they get separated. So F1 is the force acting here, F2 be the force acting here, and its weight is acting downward. So liquid is in equilibrium. Therefore, total upward force must be equal to total downward force. Downward force is F1 plus mg is equal to F2. F1 को आप क्या लिख सकते हैं? P1 इंटू ए, मास को वॉल्यूम इंटू डेंसिटी इंटू g is equal to P2 into A. This is volume is area into h into rho into j is equal to P2 into A. So P1 into A plus A into h into rho into g is equal to P2 into A. You can write this as P2 minus P1 into A. A से क्या हो गया? कैंसिल. So P2 minus P1 is h into rho into g. So if g is 0, this is the pressure difference between the 2 points A and B. If g is 0, then P2 minus P1 is equal to 0. This means P2 is equal to P. This means the pressure at both the points remain same. तो दोनों points पे pressure क्या रहेगा? Same. यही first statement थी. If the effect of gravity is neglected, then at every point in the liquid pressure is same. अब सेकेंड को हम प्रूव करेंगे एक्सपेरिमेंटली. सेकेंड स्टेटमेंट ऑफ पास्कल्स लॉ. Pascal's law. This is experimental proof. एक्सपेरिमेंटल प्रूफ. अगर आप ये सर्कुलर क्या ले लें, एक कंटेनर ले लें जिसमें 4 ओपनिंग्स हैं. This is first opening. Here the frictionless piston is there, having the area A, right? And this is area 2A. इसको आप ले लें 3A, और इसको हम ले लेते हैं दिस इज A/2. एंड इन दिस द लिक्विड इज प्रेजेंट. यहाँ आपने क्या लगाया इस पे फोर्स, इस पिस्टन पे कितना फोर्स लगाया F. तो ये पिस्टन्स कहाँ मूव करेंगे, आउटवर्ड. इफ़ यू वांट टू मेक दैट दिस पिस्टन डू नॉट मूव आउटवर्ड, तो प्रेशर कितना यहाँ क्रिएट हुआ F/A. ये कब मूव नहीं करेंगे, जब आप सेम प्रेशर यहाँ क्रिएट करेंगे. दिस इज 2F डिवाइड बाई 2A. इस पर कितना फोर्स लगाएं 2F, ताकि प्रेशर क्या हो जाए सेम. दिस इज 3F डिवाइड बाई 3A, और इस पे कितना F/2. तो प्रेशर कितना हो जाएगा F/2 डिवाइड बाई A/2. तो सब पे आपने कितना फोर्स लगाया ताकि प्रेशर क्या हो जाए सेम, राइट. सो दिस प्रूव्स द सेकेंड स्टेटमेंट ऑफ पास्कल्स लॉ. ओके, इन द नेक्स्ट वीडियो आई विल एक्सप्लेन टुमारोज लेक्चर द applications of Pascal's law. Thank you.